Hello and welcome to Creative Connections. Today we're exploring the strange but beautiful connection between light, gravity, chemistry and growth that allows a fallen tree in Clapham Woods to keep reaching upwards, even after the world around it has turned sideways. Every now and then, when you are walking through a wood, you see something that makes you stop. Not because it's dramatic in the usual sense, not because it's huge or colourful or obviously beautiful, but because it seems to be quietly doing something impossible.
And that's what happened in Clapham Woods in West Sussex. There's a fallen tree there, or almost fallen. Its trunk is lying practically on its side. At first glance, you might assume it's finished. A tree on the ground feels like the end of the story.
Except this one hasn't stopped growing.
No. And the strange thing is that branches which would once have grown out sideways when the tree was standing upright are now growing straight up. So the question is, how does the tree know?
How does it know which way is up?
Exactly, because the tree has changed position. Its whole world has been turned sideways. What was once vertical is now horizontal. What was once a side branch may now be pointing in a completely different direction. And yet somehow the living parts of the tree are still trying to find the sky, which sounds almost conscious, but it's not conscious in the way we would understand it, is it?
No, but it's responsive, and that's the important distinction. A tree does not think, oh dear, I've fallen over, I'd better grow upwards now. But it does have built-in systems that respond to light, gravity, damage, and opportunity.
So this is not random.
Not random at all. What we're seeing is the tree adjusting to its new circumstances. And the scientific word we need here is tropism.
Tropism, that's the word I'd half remembered.
Yes, tropism simply means a growth response to a directional stimulus. In other words, something in the environment is stronger from one direction than another, and the plant grows in response to it.
So light would be one example?
Yes. Growth towards light is called phototropism, photo meaning light. Most of us have seen this with a house plant on a windowsill. Leave it in one position for a while and the stems start leaning towards the window. The plant isn't choosing the window, it's responding to the direction of the light.
And that makes sense in a wood because light is everything.
It is. In a woodland, light is scarce and valuable. A fallen tree may suddenly create an opening in the canopy. Branches and buds that were once shaded may now receive much more light. That can encourage new growth.
But in the case of this fallen tree, the branches are not just growing towards the light in a vague way. They are growing upwards.
And that brings us to gravity.
So trees can sense gravity?
In a sense, yes. Plants have a growth response to gravity called gravitropism, also known as geotropism. Roots generally show positive gravitropism because they grow in the direction of gravity downwards. Shoots generally show negative gravitropism because they grow against gravity upwards.
So the roots are looking for soil and water, and the shoots are looking for light and air.
That's a good way of putting it. And it gives the plant a basic orientation. Roots down, shoots up. But the fascinating part is how this happens. It's not because the tree has a tiny spirit level inside it. It's more subtle than that.
So what is actually inside the plant that responds?
There are specialized cells that can detect the direction of gravity. In simple terms, some plant cells contain dense starch-filled structures. Because they're heavier than the surrounding material in the cell, they settle in response to gravity.
Like sediment settling at the bottom of a bottle?
Very similar as an image. Those starch bodies help the plant detect which way gravity is pulling. That information then affects the distribution of plant hormones, especially auxin.
So auxin is the chemical?
It is one of the key chemicals, yes. Auxin is a plant hormone. It helps regulate growth, especially cell elongation. And this is where the bending or reorientation happens. If one side of a shoot grows faster than the other side, the shoot curves.
So the plant is not moving like an animal moves, it's growing unevenly.
Exactly, that's the crucial point. A tree branch doesn't decide to lift itself like an arm. New cells grow, existing tissues thicken, and growth happens more on one side than the other. Over time, that uneven growth changes the direction of the shoot.
So when we see those upright shoots on the fallen tree, we're seeing the result of growth over time.
Yes, The tree is slowly rebuilding a new relationship with up and down.
That's rather beautiful.
It is, and it also explains why the older, heavier parts of the tree may still lie sideways, while the younger growth is vertical.
Because the old woody trunk can't simply bend itself upright.
Not easily. Once wood is laid down, it's relatively fixed, but the growing tips, young shoots, buds, and new wood can respond. So the fallen trunk may remain horizontal, but the living shoots coming from it can orient themselves upwards.
And that's what makes the scene look so strange. The old tree says one thing and the new growth says another.
Yes, the trunk records the fall, the new shoots record the recovery.
You mentioned light and gravity. Which one is more important here?
Both matter, but they do slightly different things. Gravity tells the plant where up is. Light tells the plant where the energy is. So in a fallen tree, gravity helps reorient shoots upward, while light rewards the shoots that reach into the brightest space.
So the tree is responding to two invisible maps.
Exactly, a gravity map and a light map. The gravity map says, grow against the pull of gravity. The light map says, grow towards the brightness. And in a woodland, those two instructions often point in roughly the same direction, upwards towards the canopy gap.
But if the brightest light came from the side, would the shoot grow sideways?
It might bend towards the light, yes. Phototropism can pull growth towards a light source, but shoots also have a strong tendency to grow against gravity. So what you often get is a compromise between the two. The plant is constantly integrating signals.
That makes the fallen tree feel less like an accident and more like a negotiation.
That's a lovely way of saying it. A tree is always negotiating with its surroundings: light, gravity, wind, shade, injury, competition, soil, water. It looks still, but it's continually responding.
And what about the branches themselves? If those branches used to be lateral, why are they now growing upright?
There are a few things that may be happening. Some of what we are seeing may be existing branches producing new upright growth from their tips. But with this tree, it probably produced new shoots from dormant buds beneath the bark. That is often called epicormic growth.
Dormant buds? So the tree has spare buds waiting under the bark?
In many species, yes. They can remain suppressed for years. But if the tree is damaged, or if light suddenly reaches parts of the trunk or branches that were previously shaded, those buds can be activated.
So the fallen tree is not only correcting its direction, it may also be waking up hidden growth points.
Precisely. If the fall opened up the canopy or exposed the trunk and branches to more light, dormant buds may have had their chance. They begin to grow, and because they are shoots, their natural response is to grow upwards and towards light.
That would explain why the new growth looks so vertical.
Yes, it may not be the original side branch turning itself into a perfect upright branch. It may be new growth emerging from that branch and then following the usual rules: up, light, space.
And what about the tree staying alive? If it's lying nearly on its side, how can it still be growing?
Because falling is not always the same as dying. If enough of the root system remains in the ground, and if the tissues that carry water and sugars are still functioning, the tree can continue living.
So it still has a supply line.
Yes, water and minerals move upward through the xylem, and sugars made in the leaves move through the phloem to feed other parts of the tree. If those systems are not completely severed, the tree may continue to function, even in a very altered position.
That makes sense. A snapped-off tree might die, but a partly uprooted or fallen tree can sometimes keep going.
Exactly. It depends on the species, the amount of roots still connected, the severity of the damage, and the conditions afterwards.
You also mentioned reaction wood. What is that?
Reaction wood is one of the ways trees respond structurally to leaning or bending. When a tree is tilted, it may produce wood with different properties on one side of the stem or branch. This helps it resist the pull of gravity or slowly adjust its position.
So the tree is not just growing leaves and shoots, it's changing the kind of wood it makes.
Yes, and this is one of the most extraordinary parts. In many broadleaf trees, the tree forms what is called tension wood, often on the upper side of a leaning stem or branch. You can think of it as wood that helps pull. In conifers, the equivalent is often compression wood, which forms on the lower side and helps push.
Pulling and pushing, two different strategies for the same problem.
Exactly. The problem is, how do you keep growing when gravity is no longer acting neatly down the centre of your trunk?
And the answer is make different wood.
Yes, the tree cannot step back upright, it can't move location, but it can alter its growth, it can reinforce, it can compensate, it can redirect.
Which is really what the whole fallen tree is doing.
It is. It's not restoring the old tree, it's creating a new version of itself from the position it's now in.
That feels like the real creative connection here.
I think so too. Because the fallen tree is a connection between physics and life. Gravity pulls everything down, light draws living green things upwards, and the tree exists in the tension between the two.
Gravity says this is where you have fallen.
And light says this is where you can still grow.
That is wonderful.
And scientifically, that is what makes the tree so interesting. It's a living demonstration of how plants sense and respond to the world. Not with nerves, not with muscles, not with a brain, but with chemistry, growth and structure.
So when someone asks what makes the branches grow upwards, the answer is not just one thing.
No, it's not just light. It's not just gravity. It's not just auxin. It is the relationship between them. Gravity gives direction. Light gives opportunity. Auxin helps translate those signals into uneven growth. Dormant buds may create new shoots. Reaction wood helps the tree deal with mechanical stress.
And together, those processes make the fallen tree look as though it's changed its mind.
Yes, as though it said, I can't stand as I once did, but I can still grow from here.
Which brings us back to Clapham Woods. You are walking through the wood and you see a tree that should perhaps be horizontal. But from that horizontal trunk, life is rising vertically.
And it makes you realise that trees are not static objects, they're slow responders.
Slow but not passive.
Exactly. A fallen tree isn't necessarily a dead tree. Sometimes it's a tree writing a new set of instructions.
Written in branches.
Written in branches, leaves, hormones, wood fibres, sunlight and gravity.
And perhaps that's why it catches the eye, because it looks like a contradiction.
A tree lying down but still reaching up. And in that one image, you can see the whole connection. The fall, the light, the pull of the earth, the chemistry inside the living tissue, and the stubborn continuation of growth. Which is why a fallen tree in a Sussex wood isn't just a fallen tree. It's a small lesson in how life responds when the world turns sideways.
And that feels like a good place to leave it.
A tree that has fallen but not given up. Still rooted, still sensing, still growing, still reaching for the light. Thank you for listening to Creative Connections. If you enjoy our work, please click like and subscribe because it helps us keep the channel going and produce better content.